7.3a is logarithms. Logarithms are something that seems a lot harder than it actually is. A logarithm is very closely related to an exponential. In fact, it's the inverse operation. So what I want you to remember here, remember two things. One, ask yourself, what is the base? What is the base? And then two, remember a log equals the exponent. We're going to be switching back and forth between logarithms and exponentials, and those two things are very useful. When we look at number 1, log base 2 of 64 equals 6. That's how you read it. So really try hard to read it just like that. Log base 2 of 64 equals 6. Log base 2. So first question was, what's the base? Well, the base is 2, and a logarithm equals an exponent. So this is the base, and this is the exponent. These directions say rewrite each equation in exponential form. So what you have is you have a base 2 with an exponent of 6. 2 to the 6th power equals 64. That's it. That is exponential form. 2 to the 6th power equals 64. I see a base 7. And since a logarithm is equal to the exponent, that says 7 squared equals 49. And that should make perfect sense to you. This says pretty much the same thing as this. They're the same numbers. It's the same thing. It's just a little bit easier to understand. 7 squared equals 49. Yeah, sure. So number 5, what's the base? 14. Logarithm equals the exponent, so that means the exponent is 0. And that other number goes here. But yeah, that makes perfect sense. 14 to the 0 power, anything to the 0 power is 1. Moving on, rewrite each equation in logarithmic form. Well, it's the same thing, we're just going backwards. So again, you got to look at what's the base and remember that a logarithm equals the exponent. This number here is the base. The base holds up the exponent. 19 is the base, so if we want logarithmic form, that's going to be a log base 19. Now remember, a logarithm equals the exponent, so it's going to equal 2. You got to put it out of order like that. Log base 19, well, the only other location has to be right here. Log base 19 of 361. Now, I want to start over here. I want you to write it in the appropriate way. So let's go back to kindergarten. When you first were learning how to write, you probably used something I call highway paper. All right? And I want you to really try hard to write these things like this. Log. And then your base 19, 19 is a subscript. So it's going to be kind of lower and a little bit smaller like that. And it's going to equal, the exponent is 2. Log base 19 of 361 equals 2. Try really hard to write with that sizing using a subscript 19. Everything else is just regular size. So again, number 9, what's the base? So that's 225. That means we're going to have a log base 225. Try really hard to make that a subscript. Logarithm equals the exponent. So logarithm equals the exponent. And the only other place has got to be right here. Log base 225 of 15 equals 1/2. Next one. Base is 6, so that's your subscript. A logarithm equals the exponent. Log base 6 of must be 216 equals 3. All right. Now, we have to evaluate. And evaluate means find the value. Find the value. So the answer to number 13 is going to be a number. And what I would do maybe if you're trying to do this without a calculator, is just write it as an equation. If you want, maybe it makes more sense to leave it as like a square. Log base 6 of 36 equals square. We can treat these exactly the same way as all the others. What's the base? Well, this one has a base of 6, right? And since a logarithm equals the exponent, that means that this thing right here, it must be the exponent. So you got your base 6, you got your exponent, whatever's in that box, and that equals 36. So you just need to fill in the blank. Well, it's got to be 2, right? 6 to the second power. 6 to the second power equals 36. So the answer to this is 2. Log base 6 of 36 equals 2. What we are finding is the exponent. And so people look at logarithms and they get super confused, but they don't understand that all we're doing when we do this logarithm is we're finding the exponent that makes it work. Number 15, base is 2, and it's equal to an exponent. So we're just finding the exponent that makes 32. Last lesson, we changed these things to where they matched. 32 could be thought of as 2 to the 5th power. That's how you would know that this exponent has to be 5. This answer has to be 5. 5. Next one, log base 4 of 16. Again, all you're doing is you're trying to find the exponent that makes this work. There's a base 4. You're trying to find the exponent that makes 16. A lot of times you can just do it in your head. What exponent makes 16? Well, it's got to be 2, right? 4 to the second power equals 16. Or, 16 is 4 to the second power. I know that's got to be 2. That answer is 2. Okay, so let's talk about some of these, maybe using a calculator. If you pull out your calculator, you might notice there's this log button right here. All right, there's a log button, but log 64 is not going to give me the answer because log on the calculator is always going to be log base 10. And problem number 1, if you look at it, is log base 2. So I don't have a button for that, but I can type it in. Log 2, like that. Log 2, 64. Oops. Equals 6. And log 7 of 49 equals 2. So then, sure, when we get down here, of course, the last one, log 4 of 16 is 2. Yeah, your calculator can do it, but you want to be able to do it without a calculator as well. It's just useful to know both. All right. On the back, we're going to graph some logarithms. And remember, a logarithm has something to do with an exponential. So we did exponential growth and exponential decay already. An exponential growth problem looked something like this. That was the curve, and it had a horizontal asymptote. That was kind of the graph of a exponential growth. Well, a logarithm is the inverse operation of an exponential. And so what that does is it switches x and y. I don't know if you remember a week or so ago we talked about finding inverses and we had to switch x and y. That was one of our steps, switch x and y. So the graph is going to basically flip, and it's going to look something like this. It's kind of like if you took that exponential growth and turned it sideways, kind of, sort of. That's what a logarithm is going to look like. So I want you to memorize this basic shape. In addition to the other basic shapes that you should know parabola and a V shape and the square root shape, all that stuff. But this is what a logarithm is going to look like. Key here is it's going to have a vertical asymptote. And if we look at number 19, here's where it's going to have your vertical asymptote. Look at this part, the argument of the logarithm, and I want you to find the number that makes that equal 0. We've talked about that before. I want to zero this out. So the number that makes that 0, pretty clear, is -5. You are going to have a vertical asymptote at x equals -5. So let's draw that in first. If you've memorized what a logarithm looks like, you already know the basic shape is going to be something like this. Okay? But how do we figure out the rest of that stuff? Well, the easiest thing I can tell you to do is make a table. And we're going to make a table and we're going to use a calculator. One thing to notice is there isn't anything over here. So I will only stay to the right of my vertical asymptote. Stay to the right of the vertical asymptote. Well, my vertical asymptote is at -5, so why don't we stay to the right of that and do maybe -4, maybe -3. I don't know how many points we need. We need as many points as we need. So we can type this into the calculator. Problem's just a regular log. log. It's not a log 7 or a log 4 or anything like that. This is the only one where you have a special button for it. This button is the log. It's actually a log base 10. But if I plug in -4, plug in -4 for x, that's going to be -4 plus 5 is 1, right? That'll be log 1 minus 5. Because I plug -4 in right here. -4 plus 5 is 1. Log 1 minus 5 gives us -5. So we have the point -4, -5. -4, -5 looks like a point right there. Okay, so let's try -3. If I plug -3 in right there for x, -3 plus 5 is 2. I'll have log 2 oh my gosh, minus 5. Log 2 minus 5. Ew. That's something that's kind of gross. -4.7 about. So you've got the point -3 comma -4.7. -3 comma -4.7, going to be like right there. Okay. So I don't know. We can plug more stuff in. Let's try plugging in 0. Let's see if we plug in 0. So plug it in. 0 plus 5 is 5. So we're going to have log 5 minus 5. -4.3. -4.3. 0 comma -4.3. All right, so that's probably enough, especially if I already know what this looks like. I know what the thing looks like. It's going to approach this curve. It's going to hit these dots. If I can hit these dots. Don't cross the asymptote. It's going to look something like that. That's not great, but that's pretty good. All right, they all look like that. So again, first thing I would start with is find that vertical asymptote. You're going to have a vertical asymptote at x equals 1. Remember, it's the number that makes that equal 0. 1 minus 1 is 0, so we're going to have a vertical asymptote at x equals 1 right here. I already know what this looks like. It's going to do something like this shape. So just make enough points to where you can figure it out. I've got a stay to the right of 1, so maybe I try 2. If I plug in 2, right there, I'm going to have log 2 minus 1 is 1 plus 5. Is 5. So 0.2 comma 5. 2, 5 right there. Let's try 3. And be log 3 minus 1 is 2 plus 5. About 5.3. 3 comma 5.3. Is that enough? I don't know. Let's try 8. You can do as many points as you want. If I plugged in 8, I'm going to have log 8 minus 1 will be 7 plus 5. Log 7 plus 5. 5.8 or so, 5.85, whatever, 8 comma 5.85. That's like right there or so. But again, I already know what this thing looks like. Don't cross that asymptote. There it is. There's your logarithmic curve. Okay, number 23. Sketch each graph, then identify domain and range of each. Okay, so this one's a little bit different because of this base 2. The others had a base 10. This has a base 2. But it's going to start off the same. What number makes that equal 0? Well, it's negative 2. So there's a vertical asymptote at x equals negative 2. Negative 2. Vertical asymptote. Start with that. I already know what the shape looks like. So then we need to pick some numbers and plug them in. Maybe start with negative 1. Remember, we want to be to the right of that asymptote. So negative 1 would be a good number to plug in. Negative 1. That's going to give me log base 2. Negative 1 plus 2 is 1. And then minus 5. Okay. Now remember, you can't just hit this button because that's a log base 10. That is log base 10. If I say, okay, let's just say log 100, that's going to equal 2. And I know that because it's a base 10, and a logarithm is finding the exponent that's going to make 100. What exponent makes 100? That's a log base 10. If I say log 1000, I know that's 3 because I'm looking for the exponent on a 10 that makes 1000. All right, but this problem right here is a log base 2. So you can't use this button. This button is a log base 10. You're going to have to type it in log 2. Log base 2 of 1 minus 5 is negative 5. Negative 1 comma negative 5. So then let's try 0. Log base 2 of, all right, 0 plus 2, that's 2 minus 5. Okay. Let me just show you something. Log 2 of 2 is 1. Of course that's 1 because we're finding the exponent on a 2 that makes 2. 2 to the first power equals 2. That's what we did on the front side. If you just type in log 2, you're going to get something crazy. It's different. So make sure you do log base 2 of 2 minus 5 is negative 4. 0, comma, negative 4. We can do some more if we want. Let's do 8. Okay. If I plug in an 8 right here, 8 plus 2 is 10. So that's going to say log base 2 of 10 minus 5. Log 2 of 10 minus 5. Ooh, is that right? Negative 1.7. 8, comma, negative 1.7. Yeah, I guess that could be right. Like this. Yeah. It's a slightly different shape than the others because it's a base 2. The other two looked identical because they're both base 10s. Well, I guess when I say identical, I mean like this curve. This curve. This is a milder curve, I guess, because of the base 2. All right, domain and range. It says, then identify the domain and the range. You may have learned the domain is the x numbers and the range is the y numbers. There's more to it than that, but that'll get you started. Okay. Here's how I look at it. I look at it as if you're talking about this curve right here, this curve, and you squash it. So let's say that the floor and the ceiling are closing in, closing in, closing in. Okay. If that happens, it's going to take your blue curve and it's going to smush it onto the x-axis right here. It's going to cover up everything to the right of that vertical asymptote. Everything that's bigger than negative 2. From negative 2 to infinity. From negative 2 to infinity. But let's just say as long as it's greater than negative 2. That can be your domain. As for the range, okay, the range, we were talking about the y numbers, and so I look at the y-axis. And so for the range, I think about the walls closing in. If the walls are closing in, it does a little bit different. This blue line, it crushes, but you got to look at the arrow. The arrow is going down forever, and then, you know, crushing this blue line, but there's an arrow on the end of it which goes up forever. That's going to go down forever. That's going to go up forever. That range is everything. That range is going to be all real numbers. Everything.